Very warm welcome, everyone. I am Sakshi Sari, Product Manager for Toxin Binder Solutions at Chemin Industries South Asia. And in today's episode of MycoTalks, we have with us Dr. Yuvraj S, Associate General Manager for Chemin Customer Laboratory Services. And today we'll be discussing on how contamination risks have been evolved and what are the emerging risks and the proactive management solutions.
Hello, hi. I'm Dr. Yuvraj S. I had been working as an Associate General Manager in Chemin Customer Laboratory Service, and I have been with this team for quite some time. This particular team works on mycotoxin analysis and also on the nutrition analysis, on many microbial analysis.
So, sir, let's start by understanding what are the current contamination trends and how has climate variability and raw material sourcing has influenced the trends in the recent years for raw material and feed samples.
Considering India being a tropical country, you can always very well appreciate the growth of mold in many of our food items as well. So what it says is the environment is absolutely conducive for the growth of mold. So when any mold grows, naturally there will be some production of metabolites from it. So those metabolites are the mycotoxins. So based on the seasons and based on the weather conditions, the mycotoxins might vary. But you can expect one or other mycotoxins to grow and to get into the feed ingredients through which it comes to the feed materials. Yeah. So what our observation throughout this last 5-6 years data is, considering Aspergillus being the dominant type of mold in the Indian scenario, we are getting lots and loads of Afla B1 contamination in the feed materials. In addition to that, we also do see occurence, some amount of occurence, and also a good amount of zearalenone as well in the feed materials. So these things, if you see, it is not absolutely like the same mycotoxin going to come from all the ingredients. Based on the materials, there will be slight variations in the mycotoxin, and also the season would have an impact on the type of mycotoxin what you can expect. In the summer, Bihar and these regions, what we have appreciated is very high load of Afla B1. And as during the monsoon season also, we do see a lot of Afla B1 along with occurotoxin in the maize, or some amount of occurotoxin. We do occurotoxin and T2 we see in rice as well. Routinely at customer laboratory service in Chennai laboratory, we conduct lots of mycotoxin analysis. And monthly, we would do around 400 to 500 plus samples for the list of mycotoxins like Afla B1, occurotoxin, zearalenone, citrinin, cyclopyrazonic acid, and also sometimes for the mycophenolic acid as well. So in these, what we have seen is on an average around 500 plus samples on a monthly basis. So and it comes from different zones of different regions of India, including from south, north. From all the poultry growing regions, we get the samples and the samples gets analyzed. In 2025, we could see around we did around 4,000 to 4,500 samples for the mycotoxins alone. It includes feed ingredients and also the complete finished feed as well. When we look at the raw material that is commonly used in the poultry feed, the maize samples are the most common ingredient, which has the higher load of mycotoxins, followed by this maize gluten, or then the GNDOC, and also DDGS samples. Maize DDGS samples naturally has little higher load of mycotoxins than the rice DDGS. And the average aflatoxin load in the feed would be around 35 to 40 ppb. This is what we have observed in this last 2025 data. And it has been more or less steadily this trend. The slight increase trend happens comparing to the earlier 4-5 years data. In maize samples, an average of 40 to 45 ppb. This is what the average aflatoxin load what we have seen in 2025 out of some 400-500 samples what we have tested. Odd samples also we have seen some samples having 800 ppb of aflatoxin also. That is the maximum level what we have observed in the maize samples. And one material which you can always suspect for the mycotoxin is a GNDOC. In the groundnut DOC, the mycotoxin load is very high. First would be the afla-B1. Afla-B1 in our GNDOC, in one of the sample we have even recorded up to 20 ppm level. So our average itself, you can get at least some 300, 200 ppb of afla-B1 in GNDOC samples. And maize DDGs also, what we have observed is out of 10 maize DDGs, 7 to 8 DDGs, maize DDGs samples are having positivity for the afla-B1 load. And rice DDGs, yes, naturally it has some amount of toxins, but it's not that high as like maize DDGs. Rice DDGs has little lesser load, and average would be around 25 to 26 ppb levels. In addition to the mycotoxin load, one another thing what we are looking at recently is the pesticide contaminations. Pesticide contamination happens in what we are observing is in isolated cases, but whenever these pesticide challenges comes in the field, we are seeing severe challenges in the field, because we have a team of technical members working in the field. They do send the samples wherever they are suspecting. In many of the samples what we have received in the suspected samples, we have seen some amount of pesticide contamination in it. This pesticide is one another thing which we will have to look at in future, contamination in the feed materials as well.
Now, while testing is very critical, the accuracy of these results depends heavily on how the sample is collected. So, can you tell us how important is sampling and the detection methods, and what are the critical gaps that have you observed while the process of sampling is done?
Yep, this is a very important question, and when we look at mycotoxin detection, because mycotoxin is not like other nutritional thing. It is not equally present in all the materials. It is going to be in very much hot spots. So it is going to be like if you take a ton of maize, it is not going to be equally present in our entire ton of maize. It happens in one or two spots where the good amount of growth of mold has happened, and in those materials, these mycotoxins tend to attach to the maize grains. So what we observed is when we look at do the physical examination of the maize, when we take the maize, some 100 gram of maize, we put it in a plate, and when we observe it, we see like we don't see the black spots in all the maize grains. We only observe in few of them corn grains. So that means like that is the place where this mold growth has happened, and mostly in those areas alone, the mold growth, the mold contamination would secrete some metabolites of mycotoxin in it. So when we look at the sampling, considering this, the sampling becomes very much critical in doing the taking up the sample for analysis. What I would always suggest is when you are sending the sample for mycotoxin, don't just open one bag of maize and take the sample and send it to the laboratory. Just you do multiple sampling, and all the multiple samples you put it together, and you do a proper quartering technique. This way, you will be able to identify an average aflatoxin load in the entire lot. But this is very much critical when you are doing the mycotoxin analysis. In our experience, we have done like from few bags in a ton of feed, we have collected the samples. When we did the analysis, each bag was having different loads of mycotoxin. When the sample was taken and when the samples was collected individually and analyzed, and putting together and all the samples and doing a quartering technique and analyze, we could get closer to the average value what we can expect. And another thing on the mycotoxin analysis, the detection methods. There are several detection methods for the afla-B1 analysis. Mycotoxin, generally we will discuss more on the afla-B1, because considering India being a tropical country, and the most prevalent is the afla-B1. For the afla-B1 analysis, you can do by 2-3 different techniques. One would be the rapid kits. A lot of commercial kits are available in the markets that can be used for doing the analysis. And the next is you can very well use the TLC analysis, or the thin layer chromatography, or the HPLC analysis. HPLC analysis and TLC analysis needs a skilled person, because the person has to get trained in doing these analysis. Another method of analysis is for the is like ELISA technique. ELISA technique is also a commercial kit where when multiple samples are there and the analysis has to be carried out in a quicker time. So this is one thing which we can look at, which we can consider.
What proactive steps do our customers need to take to stay ahead of the toxin risks?
See, when it comes to mycotoxin, there is no one single bullet to cure this. So it is going to be a multiple thing we'll have to look at. So first and foremost thing, it starts from how we are going to source this material. And given the thing that we are going to, the entire thing, we are not having too much of material in abundance for the feed production, considering the limited sources of grains available for our feed production. So we should be critically evaluating whatever material is available, and we'll have to, like as I said, being the sampling being highly critical in the analysis. So a proper sampling has to happen, and all the material, and as much as bags of maize or as much of bags of oil cakes has to be opened, and proper sampling has to happen. And once these materials are analyzed, so based on the load of mycotoxin in this materials or in the grains, you have to properly identify which material can be sourced to our feed mills. Another thing what I would suggest is when we are looking at considering the lot of grains and things available, when we are going for storage of maize, I would say that it is better that if we can put a proper cleaning measures for the maize, that would reduce to a level the load of mycotoxin. Because what we have seen is the maize grains are having small black spots on the tip of the grain, on the grain tip. So when we are doing a proper cleaning of this material, some amount of toxin tend to get loosened up from the grains and it falls off. This has been observed, like when people are loading to the silos. So the loading of silo, before the loading of silo, people tend to clean up the grains. So this in a way reduces some load of mycotoxin that is adherent to the maize grains. So this is one strategy we can look at in cleaning up the grains and using it, and considering the GN sort of material which is highly prone to mycotoxin load. So what we can do is those materials during the young age, it is better to use it at a lesser levels than the higher age of finisher and things.
Results are just the starting point. It's all about how numbers are turned into decisions. So in what ways does Chemin CLS team partners with our customers to move from the detection stage to informed mitigation and long-term risk management?
This is very important thing to look at, because doing the analysis is one thing, and how this result is getting interpreted to take a decision is the next thing that is going to make the difference. See, when we do a lot of analysis on Chemin CLS, and many times, like the grains before production, if it comes to us, we'll be able to do some analysis and we'll give the results to the customers. That will be useful in taking decisions for the customers for that particular batch. Another important activity what we do at Chemin is we collate all the data of years together, and we start doing some trend analysis. So this is one thing which will be helpful on before taking a decision what to expect in these sort of grains, in these sort of oil cakes. This is one important critical thing what we are doing at Chemin CLS. And other thing what Chemin is doing is, what we can see is, like what we do is we send these results to our technical managers who are locally present in that particular geography. So by looking at this report, they'll be able to understand and identify what is the real problem, considering the farm challenges and the feed results. They should be able to identify the problem easily, and they will communicate the appropriate suggestions to the team to take, and how to reduce the impact of mycotoxins in the feed and ingredients.
So it's very clear that toxin management these days is very complex, and it's not just about testing, it's about connecting the dots and making right decisions at the right time. Because in the end, it's not just about detecting the risk, but also staying ahead of it. That's it for today. Stay tuned for next MycoTalks episode.